So continuing further, in chapter matrices, we found the inverse of the given matrix by the elementary transformation, whether it was row or column, right? So there you need to follow certain, operations step by step to convert the matrix into an identity matrix, and then accordingly you get the inverse. But that is a very laborious task. I think we are on the same page. But in order to find this inverse of the same matrix very easily, there is another rule, method to find the inverse, which says that, as I told you, okay, in my previous lecture, that the in order to have the inverse of the matrix, what should be the condition? The determinant of the matrix should not be equal to 0. It should be non-singular, right? So you can see that the determinant of A is coming in the denominator. So for any square matrix A, if I need to find its inverse, it is given by this formula. A inverse is equal to 1 upon determinant A into edge A. This is a very important formula, children, in order to get the inverse of the given matrix without doing the row or column transformation, right? So this forms a very simple tool. That's the reason that determinant A, okay, it should not be 0. If it is 0, so 1 upon 0 turns meaningless and you cannot find the inverse. That's why it is very clearly mentioned that a matrix is only invertible if and only if the determinant A is, or the matrix is non-singular. That means the value of the determinant A should not be equal to 0. So let us quickly take an example to find the inverse of the given matrix using this formula.